Good morning everyone. Today I am going to take a lecture of probability and statistics, chapter number 1, basic probability. And the topic is the conditional probability. Conditional probability is very important topic in this chapter, basic probability. Okay, so we have already seen in the introductory session what is the conditional probability. So in case if we are given in the two conditions, that means we have the, for example, we have the two events and one event is completed, after that second event is started. Okay, that means one event is completed and after that the second event is started, then this type of the question included in the conditional probability topic. So in the conditional probability we are given in always in given in one condition, that means one process is completed, after that second is started. Okay, so in case if we are given in the two conditions, in according to your question, if we are given in only two conditions, so you use the conditional probability formula. But in case if we are given in more than two conditions, that means 3, 4, 5, 6. Okay, so this type of the question depends on the Bayes rule. Okay, Bayes theorem. That means Bayes theorem is depends on the conditional probability, but conditional probability in the basic conditional probability we are given in only two conditions. Okay, but if we are given in more than two conditions, then we use the Bayes theorem. So conclusion is what? Conclusion is that Bayes theorem is also depends on the conditional probability. Okay, and how we decided that this question is depends on the conditional probability or Bayes theorem. So first you read carefully. After that you decided that if in this question any conditions are given or not. Okay, so what is the conditional probability? So here the definition is let capital A and capital B be any two events of a sample space S. That means S is a universal set. For example, S is a universal set and A and B be any two events of a sample space S. Okay, then the probability of the occurrence of event A when it is given that B has already occurred. That means B event is already completed. After that, A event is started. Got it? So here, read carefully. Then the probability of the occurrence of event A when it is given that B has already occurred is expressed by the symbol probability of A slash B and is defined as, that means defined by, that means A event is occurrence when it is given that B has already completed. Okay, so here first event already completed. Then what is the first event? First event is what? Completed event. So completed event is B. So here we write A slash B. That means B event is completed. After that A event is start. Okay, that means the completed event we write here the stage form. That means B is completed, after that A is started. For example, we write here the B stage. That means what? A is already completed, after that started the B event. Okay, that means one event is already completed. We write here the slash B slash A slash C. Okay, and in this side, in the left hand side, we write here the next event. Okay, so here the probability of E slash B, that means what? B event is already occurred. After that, A event is started. So A slash B is equal to probability of A intersection B divided by probability B. This is the formula of the conditional probability. Okay, if we are given in only the two events, two conditions, and here the one condition is for probability B always greater than 0. Okay, next one is if we write here the probability of B slash A. That means what? Probability of A intersection B. A intersection B, that means what? The both common number. Okay. So we write here A intersection B or B intersection A. Both are equal. Okay. So we write here B slash A. B slash A probability is equal to what? P A intersection B divided by the probability A. And here the condition is what? Condition is probability A greater than 0. Okay, for example, we are given in the three conditions. That means, for example, we are given in A1, A2 and B condition. That means A1, A2, any event and B is also any event. But B is completed after that A1 and A2 started. Okay, so here the probability of A1 union A2 slash B is equal to probability of A1 slash B plus probability of A2 slash B minus probability of A1 intersection A2 slash B. And here the condition is probability B greater than 0. Okay, so here this is the example of if we are given in the three conditions A1, A2 and D. Okay, so this is one example depends on the condition probability. Let A and B be two events with probability of A is equal to 3 by 8, probability of B is equal to 7 by 8 and we are given in the A union B is equal to 3 by 4. Okay, and we find the value of probability of A slash B. Okay, so we find the probability of A slash B. So first we write the formula of probability of A slash B. That means what? That means probability of A intersection B divided by the probability of B. Okay, so according to our question, we are given in the value of the probability of B is equal to 7 by 8, but we write here the value of probability of A intersection B, but this value is unknown because we are given in the probability of A union B. Okay, so first we find the P A intersection B. Okay, so how we find the P A intersection B? So in our previous lecture, we have already seen the formula of the probability of A union B is equal to, what is the formula? Formula is probability of A plus probability of B minus probability of A intersection B. Okay, this is the formula of the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay, so in this formula, we put here the probability of A union B because of this value is already given in your question. So we put here the probability of A union B, that means 3 by 4 is equal to probability of A is equal to 3 by 8 plus probability of B. So probability of B is equal to 7 by 8 and we find the value of probability of A intersection B. Okay, so here the probability of A intersection B is equal to what? Here we write here the PA intersection B in the left hand side, so this minus sign is converted into the plus sign and this 3 by 4 we write in the right hand side. So 3 by 8 plus 7 by 8 minus 3 by 4. Okay, we write here minus P A intersection B in the left hand side. So this minus sign is converted into the plus sign and this 3 by 4 we write here the right hand side. So this plus sign is converted into the minus sign. Okay, so solve this stage. So this is the 7 plus 3, 10 by 8 minus 3 by 4. That means 4 to the 8. So 10 minus 6 divided by 8. That means 4 by 8. That means 1 by 2. So the probability of A intersection B is equal to what? 1 by 2. Okay, so this probability of A intersection B is equal to 1 by 2. We put here in this formula. That means here we write the equation number 1. So we put here the equation number 1. So probability of A slash B is equal to what? P A intersection B. That means 1 by 2. Okay, divided by the E B. So 7 by 8. So here we write the 7 and here we write the 8. Okay, because of this term is 1 by 2 divided by the 7 by 8. So don't be confused here. 1 by 2 into 7 and 8 we write in the numerator form. So 2 4 ja 8. So this is the 4 by 7. Okay, so 4 by 7 is the answer of the probability of A slash B. Okay, for example, we find the probability of B slash A. So what is the formula? Formula is probability of A intersection B divided by the probability of A, because of here we write the probability of B slash A. Okay, that means A event is already completed. After that, B event is started. Okay, so process is same. First, we find the A intersection B. So you use the formula of probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. After that, you put all these three values and we get the value of probability of A intersection B. Okay, and then we put this formula, so we get the value of the probability of B slash A. Okay, so this is the example of the conditional probability. Okay, so this is the example of the conditional probability. This example is very important. In producing the screw, let A main, that is event A main, is screw to slim and B main is screw to short. One is slim and second one is the short, and A and B two events. A is slim and B is short. Okay, next one is the let probability of A is equal to 0.1 and let the conditional probability that a slim screw is also too short. Slim screw is also too short. That means what? The first one is the screw is too short. After that the slim. Okay, so here read carefully. The conditional probability that a slim screw is also too short. That means first this screw is short. After that this slim. Okay, so short screw, that means we write the B event and slim is A event. So we write here the probability of B slash A. That means screw is slim is also too short. B probability of B slash A is equal to 0.2. That means here B slash A, that means what? A event is completed, after that B event is started. That means these two conditions, that means A, that means slim. So that is slim screw is also too short. That means screw is slim but also too short. So first one is the slim screw, after that the short screw. Okay, so probability of B slash A is equal to 0.2. Next one is the what is the probability that the screw that we pick randomly from the produce will be both too slim and too short. So here in this question, both the too slim and too short. That means we use the intersection sign. Okay, so let's start the solution. In this question, we are given in the probability of A, given probability of A is equal to 0.1 and the probability of B slash A is equal equal to 0.2. That means screw is slim, but screw is also too short. Matlab means first one is slim and also too short. So slim is that means A. So first one is A event and after that the B event. Okay, 0.2. So the final value is what? The screw. What is the probability that the screw that we pick randomly from the produced will be both too slim and too short. That means we find the intersection because of both are included A and B. So here we find the probability of A intersection B. Okay, so in this question we are not given. This question is depend on the conditional probability. Okay, but you understand that here the condition word is already included, and if the conditional word is not included in your question, so you read carefully and just identify that this question is depend on the condition or not. That means what? Two events or more than two events if we are given in any question. So first you check here the one condition is completed, after that the second is started. Okay, so here the P A intersection B we find the value. Okay, so first one is the P B slash A. That means what? The probability of A intersection B divided by the probability of A. Okay, this is the formula of the conditional probability. And we have the both two values, probability of A 0.1 and probability of B slash A 0.2. And we find this value. So probability of A intersection B is equal to what? This is on one value, so multiply both the values. So probability of A into probability of B slash A. Got it? So put here the probability of A is equal to 0.1 and probability of B slash A is 0.2. So solve this term and we have the value of 0.2. Probability of A slash B 0.02. Okay, so the question is very confusing. We can say that the confusing question, but the answer is very easy because of always you read carefully and first you identify that this question is depends on the basic simple probability question or the conditional probability question. Okay, if your question is in the conditional probability question depends on the condition, so this term is also included in your solution. B slash A or A slash B if we are given in the three events just like the A1, A2 and B event. So you also included the A1, A2 and B events. Okay. So this is the example of the conditional probability. Okay.